It's that deductive argument trying to prove a creator based on the idea that the universe had a beginning.
That's it. Stated very simply. Premise 1. Everything that begins to exist has a cause. Premise 2. The universe began to exist. Conclusion. Therefore, the universe has a cause.
And that cause is argued to be a necessary uncaused creator, i.e. God. For the conclusion to hold, both premises have to be solid.
Absolutely. If either premise falls, the deductive argument fails. Let's tackle premise 1 first. Everything that begins to exist has a cause. Why do many modern physicists say, well, hang on?
Because of quantum mechanics.
Precisely. It seems to fail empirically at the quantum level. We observe stuff happening all the time. Radioactive decay of an atom, an electron jumping energy levels, virtual particles popping in and out of existence in the vacuum.
And these things are spontaneous, unpredictable.
Yes. And crucially, they seem to occur without a direct cause in the classical sense we usually think of. We can calculate the probability that a specific uranium atom will decay in the next hour, but we cannot predict when it will decay or what causes that specific decay event at that moment. It just happens, probabilistically.
So the idea of universal causality, that everything needs a prior cause, seems to break down at the most fundamental level we can probe.
It certainly appears that way based on our best understanding of quantum physics.
Mm-hmm.
And this has a really interesting theological knock-on effect too, doesn't it?
How so?
Well, if the very fabric of reality operates on this inherent randomness, this quantum indeterminacy, how does that fit with the idea of a meticulous designer who has specific purposes in mind for every single detail, a God who planned everything out precisely?
Right. A God relying on uncaused, spontaneous quantum events seems different from the classical image of a grand architect meticulously placing every brick.
It introduces a level of randomness, or perhaps freedom, into the system that seems to clash with some traditional notions of deterministic design. It makes the classical KCA premise problematic, even from a theological angle sometimes.
Okay, let's look at premise 2 then. The universe began to exist. This was traditionally linked to the idea of the Big Bang starting from an infinitely dense point, a singularity.
Yes, and for decades, apologists really leaned on the 1970 Hawking-Penrose singularity theorems. These mathematical theorems seem to prove that, under general relativity, if you trace the universe back in time, you inevitably hit this point of infinite density, infinite temperature, infinite curvature.
The singularity, which was then interpreted as the absolute beginning of space and time itself, the moment of creation.
Exactly. It seemed like science had proven the universe had a definite start, fulfilling premise 2 perfectly.
Yeah.
But, and again, there's a but.
What was the limitation of those 1970 theorems?
Their biggest limitation was that they relied only on Einstein's general relativity. And we know general relativity is fantastic for describing gravity on large scales, planets, stars, galaxies, but it breaks down completely at the extreme conditions found at the center of black holes and, crucially, at the very beginning of the universe.
Because it doesn't include quantum mechanics.
Bingo. You need a theory of quantum gravity to describe that initial state, and we don't have a complete one yet. But we know enough about quantum effects to understand what happens as you approach that supposed singularity.
What does happen?
As you get down to the Planck scale, the Planck time, 1043 seconds, and Planck length, 1035 meters, quantum fluctuations of space-time itself become dominant. The smooth geometry described by general relativity dissolves into a quantum foam. And in that realm, the concept of a single, infinitely dense point, the singularity just doesn't hold up.
So Hawking himself later revised this.
He did. He stated quite clearly that once you consider quantum effects, there was in fact no singularity. The universe likely began with a finite, although incredibly small, size and finite density. It wasn't an infinitesimal point emerging from absolute nothingness. It was likely a transition within the laws of physics from a quantum state.
So premise 2, interpreted as the universe began from a singularity, is likely false based on physics beyond general relativity.
It appears so. The universe had a beginning in the sense of our current expansion phase starting, but likely not from the classical singularity that the KCA often relied upon.